Hello friends, detecting patterns with unsupervised learning. In this video, we will learn about clustering. In our previous sections, we were dealing with data that had labels associated with them. When we have label training data, the algorithms learn to classify data based on those labels. But in the real world, we might not always have access to label data. So what will now we do now? So what is best technique we can use for unlabeled data? So that is your unsupervised learning. Now what is unsupervised learning? So unsupervised learning refers to the process of building machine learning models without using labeled training data. So in that case, we do not need any labeled data. Unsupervised learning algorithms attempt to build learning models that can find subgroups within the given dataset using some similarity metric. So what these algorithms do, they can find subgroups in the dataset. So in our dataset, this technique will find some subgroups, and these subgroups will depend on some metric, some similarity metric. So next is your clustering. So what is clustering is one of the most popular unsupervised learning technique. This technique is used to analyze data and find clusters within that data. So basically, unsupervised learning technique is your clustering, and that technique is used to analyze data and find clusters. That is your subgroups within your data. That is classifying your data and creating a model like that. So clustering is the process of organizing our data into subgroups whose elements are similar to each other, and these similarity will depend on your any similarity metric. Our goal is to identify the intrinsic properties of data point that make them belong to the same subgroup. There is no universal similarity metric that works for all the cases. It depends on the problem at hand. So similarity metric will depend on your problem, on your task, that what kind of task is present at that time. Next, clustering data with k-means algorithm. Now we are using k-means algorithm for clustering our data. Now what is k-means algorithm? In order to use this algorithm, we need to assume that the number of cluster is known beforehand. So before using this algorithm, you must know about number of clusters. We then segment our data into k subgroups using various data attributes. So we start by fixing the number of clusters and classify our data based on that. The central idea here is that we need to update the location of these k centroid with each iteration. So we will apply iterations, and k is denoting your number of subgroups. So we will update the location of k centroid with each iteration. We continue iterating until we have placed the centroids at their optimal location. Now what is the meaning of that? So what it do internally, the basic k-means algorithm places these centroid randomly where k-means plus plus chooses these points algorithmically from the input list of data points. So data points is your data set. You are giving data set, and internally it is using k-means plus plus, which is internally present in this algorithm. It will choose the particular location of the centroid in each iteration. It tries to place the initial centroids far from each other so that it converges quickly. So this is the basic initialization here, that it tries to place the initial centroid far from each other. We then go through our training data set and assign each data point to the closest centroid. So this is the basic method which is applied here. Once we go through the entire data set, we say that the first iteration is over. We have grouped the points based on the initialized centroids. So what is happening here? Once we go through the entire data set, we say that there is first iteration. So this is your first iteration, and then we have grouped our points based on the initialized centroids. We now need to recalculate the location of the centroid based on the new clusters that we obtain at the end of the first iteration. Once we obtain the new set of the k centroid, we repeat the process again, where we iterate through the dataset and assign each point to the closest centroid. So this is the basically internal processing of that algorithm, in which we are doing iterations, and in each iteration we are updating location of our centroid, and finally we are getting the equilibrium location of these centroids. So after a certain number of iterations, centroids do not change their locations anymore. This means that we have arrived at the final location of the centroid These k-centroids are the final k-means that will be used for inference. So this is your final k-means algorithm. That is your final location of the centroids you have found. And now let's apply this clustering on two-dimensional data to see how it works. So now we will see that method using a program in Python. Okay, so let's see it.